Hello Earth, this is episode 15 of season 2 of Making Cell, a series of videos where I record myself designing and implementing a programming environment called Cell. If you're just tuning in for the first time, you can go to github.com/howtocodeandall/cell, link in the description to know what this is about, or jump to the first episode. We're going to continue where we left off yesterday. Actually, not even, because I had a couple ideas that I want to put in the readme, at the top of the readme. And I figured, why not make this even more boring and actually record myself not just implementing the code, but also the ideas. So let's do that live. And so basically what I wanted to understand is, we're in May 2025 right now, and many of us, well, not me, although I wonder, think that generative AI is here and it's going to basically do all the coding. So basically all the information systems or the data systems that I talk about here are going to be made by AI. So what is even the point about doing anything ourselves? So I actually thought about this, and I think I brought it to three things. Let's say we have AIs for making the systems for us, kind of, because we have to ask them what we want and also check their work. So what do we need from a system so that a system that makes systems so that we can interact with AI to create our own systems? And I think there's about three things really. There's no need to say small systems. Are a great starting point for creating data systems, but exclusively, yeah, this is not well thought out. What I want to say is, can we just ask AI to create systems for us? Yeah, it's a good question. I guess more than the problems here, what I want to say is, we can just say this. If you want to build data systems using AI, my contention is, if you want to build data systems using AI and keeping them scalable is the word, you need to do three things. Host a system somewhere. The system has to be accessible on a continuous basis, and its data has to be both secured and backed up, so it needs to be hosted somewhere. The second is like control the system. AIs, like humans, are fallible and inconsistent. It is very important to make parts of the system to have rigid parts in the system that enforce certain constraints on certain constraints. So you don't want the infinite flexibility of AI. You want also to set some things in stone, and the AI can actually help you set them up. But once you set them up, it's not the AI doing this over and over. To understand the system. AIs, also like humans, get lost in a system when it becomes too complex. Having a tool set, an approach that minimizes complexity can help both human and AI to understand the system and keep it maintainable and scalable. So those are my points basically. So intends to make the host in control and understanding of the system, of your system, to be as easy as possible. Even if you're not a programmer. So that you can build, I know this is not the idiomatic, but I want the emphasis. This is, I'm going to put the 7 power-ups here. Comes from 7 power-ups. 7 power-ups. So I put the power-ups here. Then I have the use cases. Do we still need programming tools? Host the system, control the system, and understand the system. Okay. Okay, that's what I wanted to do in the intro. So now, for this time to outcome, maybe I'll talk about it somewhere else. It's a loose idea. I'm gonna leave it for later. Okay, now we're going to go back to the annotation of the code. Yesterday I fixed a bunch of stuff, and of course I need to recheck now my entire annotation, but it's okay. This is the same. Yeah, this one is also done. Yeah, this one. The unescape literal quotes is gonna be called unescape, unescaper. Sure, why not? So I know it's completely out of sync. I'm gonna work on it right now. Let's move this here. We now define an escaper, an utility function that does two things. Removes the slash that takes text and returns a string, and also returns text with two modifications. Removes a slash from before each literal double quote. Example, would be have something like foo becomes removes the slash that escapes a slash a literal that happens to be at the end, no, just before. I'm laughing because it's so unlikely, this thing. Removes the slash that escapes a literal slash that happens to be just before a non-literal quote. Okay, I'm gonna try to stop laughing. So, for example, what was the example? Because I forget. This is so involved and unlikely that I forget. Maybe the way to do it is to just yeah, that one. Yeah, space. I'll do it without the quotes because it's more confusing. No, but yeah. The question is, why am I not doing this on literal quotes or on I'm gonna put this here. I keep on finding this out this here. A major assumption here is, which is fulfilled by the way we use this function, is that text, any double quotes that are in text are literal double quotes. there is a space in this text, it has to be surrounded by literal double quotes. Therefore, if the text ends with 2 slashes, we remove the last one. This is a very, very involved corner case. We return text and close the quoter. So that's why we use lexers and parsers. Although I'm still happy I didn't do it the normal way. As usual, now so output start is we set output start to be the first non-literal quote. Hace mucho tiempo, yeah. So to the index of the, sure, that much is clear. You know what? I did this before. Oh, look at that. Is this the same? Yes, 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 yes. Yeah, this is fine actually. Yeah. Yes. Oh yeah. That was a good catch there. Dun, 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 dun. Dun, dun, bam, bam, bam. I wonder whether my singing in this series of videos is a feature or a bug. I honestly have no idea. Yeah, okay, this is there. Takatuku, takatuku, takatuku. We have the quarter. I can't believe it. We are now ready to, because what we did before. Deal with whatever comes after the indentation, if there was any. We first deal with the case where we are inside multi-line text. I'm already seeing ways to yeah, because that's outside the while. What makes multi-line text particularly interesting is that it spans lines. Therefore, our outermost loop, which goes over lines of text, could go through a few iterations and still be assembling a single path. That's why we deal with this case quite separately from the while loop we will write afterwards. Que es lo mismo. We get the quoted, we run the line through the quoted. If there is no non-literal double quote, the entire line belongs to the last element of the last path. There already has to be a path with at least an element there, which was initialized by the beginning of the multi-line text we are still processing. Therefore, we just push the entire line into it, concatenate, append into the last element of the last path, also taking care of adding a new line that we removed when we iterated to iterate each of the lines of the original text. We return so that we can move on to process the next line. If there is a non-literal double quote, we are going to close the last element of the last path. We start by appending to it this. I don't understand. Why is it +2? I remember we went through this, but this is a start, not an end. Oh yeah, because the start is just yeah, exactly, yeah, never mind, I know what. The line up to the double no, I don't understand it again. Let me just do this. The line is basically we're just chopping off stuff. Exactly, now I get it. Let me switch the record. This is not bad. Actually, let's stick with this. Yeah, let's stick with this. Yeah. Next, we chop off the beginning of the line up until the first non-literal double quote. We also remove the space after it. We set path to last path. Since we might, if there are further elements in line, we want to add them to the path we are working on. We also said unset the multi-line text flag. This concludes the multi-line text case. All right. This goes away. We now repeat an inner loop until there are no characters left on the line. If there is still a space after removing the space after the previous path element, we report an error. We are intolerant of double spaces in text. And stop the iteration. We first deal with the case where line starts with a literal double quote. We run the line through the quarter. If there is no end, no second non-literal double quote, we have just if there is a second non-literal double quote, we start by pushing the text between them into the current path as a new element. What happens with numbers here? Yeah, this case is there's a bug here, because if this is a number, this one, no, because I'm inside a quote, so all of it has to be text, cannot be a number. Yeah, see? Yeah, exactly. Now, you may ask, what if the quoted text is a number? We'll be adding it to the path as text. However, because it was prepended by a non-literal double quote, it has to be text. We chop off the line I found an inconsistency here. We chop off the line up until the second non-literal double quote. Here we check that the first element, the first character after the double quote is a space. If it's not a space, we return an error. Otherwise, we remove the space from the line. Note we don't do this in this case here. Look, here we do +1. And here I would do something like this. But I want to add a case that will make this test fail if this thing is not checked. So I will do no space after a multi-line. Just multi-line full. Yes, look at that beauty. Yes, yuppie. And if we do this, yeah, exactly. And let's also make it more consistent. First we push the path, then we mangle the line. Yes. We're going to change the order here. Yeah. We check if there's a space after it. If there is not, we return an error. Otherwise, we remove this. Is awesome because that's what I mean, sorry. So like this. Yeah, exactly. What am I doing? Sorry. Oh yeah, it was right. Perfect. Look at that consistency. This is starting to look good. Actually, let's deal with the cases that are around. Pero aquí estoy. If there is no second non-literal double quote, we just opened a new multi-line text. We set the flag. Then they continue. Wait, well, how was it before? The continues for both. I see the point. I see what you did. Then we push the entire quoted text plus a new line to the path as a new element. We then set line to an empty text. If there is, give me the else. Yeah, this is all the same. If we found one or two non-literal double quotes, we call continue so that we go to the top of the while loop. We are here. There are no non-literal double quotes in line. We proceed to split it by spaces and get its first element. If there's a white space character that's not space, we return an error because those should have been enclosed between non-literal double quotes. If there is a double quote in the element, we also return an error because this means there is an escape quote. And actually, just to make more sure I understand this test case, let's break it again. Yes, one. Yeah, exactly. Yeah, there's like a quote there. Yeah. Just a quote in the middle of it. Because it was not properly escaped. Let's do this. We push the element to the path. Note that we convert it to a number if it's indeed a number, not surrounded by non-literal double quotes. And then finally, we chop off the line up until the end of the element, plus one character. Unlike the previous two times we did this, one for multi-line, one for being within quotes. We don't need to check if there's a space after element because we split the line by spaces in the first place. This closes the while. Line is now empty. Let me try to understand this code and this comment. Before we close the iterator function on each line, let's just do this. If we just close the multi-line text on this line, path will still not be in paths, which is our output object. In that case, we push path to path. What I don't understand is why it wouldn't be part of it. The last thing we do before closing. What's true is yeah, I get it. Okay, give me a sec, I'll be right back. All right, I'm back. What was I? Yes. What I wanted to say is we finish by adding pathsToPaths. Normal, most of the time, path will not be yet in paths. However, if we opened a multi-line text on in the previous line, path will be already in paths. Therefore, we check whether paths is inside. Sorry, before adding it. Okay, now I get it. Nice. Outside of the loop that goes line by line, we check whether we got an error. If we do, we return it wrapped in a hash. If we are still, if the flag that marks we are at multi-line text is still set, there's an error. We report it. If we are here, the parsing was successful. We return paths and those text to path, and that is the parser. Whew. All right, let me enjoy the moment. All right, I'm satisfied now. So now what do? We commit. Not many changes here, just the good ones. I now understand how the parsing works. The parsing I do here, not parsing in general. I'm saving something for, I don't know, when I'm 45. Can't get enough of those tests passing, apparently. Okay, let's actually now do this. Vroom. Sure. Oof, look at that brightness. Now, where were we? Was it 10 episodes ago? Nah, of course not 10. Was it 12? Why is it empty? Some stupid. It's not empty. Was it 11? Yeah, here I was so high and what was the thing that broke it? Yeah, I can do something like well, I had a K and V P foo Oh no, what happened? Why did I break it? Friend cat table. I am not at ease with what just happened. Did you see that? Yeah, there's something going on here, of course. Unfortunately, why do I keep on breaking my own client? Ah, because I have to fix pathsToText, right? Oh, yeah. I need to fix pathsToText. Oh. And I thought I was done. Ha. Wow. Yeah, I need to de-escape things, right? Yeah. Have a quarter. And I could chicken out and send the paths as they are. This is a moral blow. Okay, I need to change the record. Let's just do a classic here. Yeah. So first, let's make sure that this is properly set. This is good. I'm putting p foo. Let me just move this for a second here. So we have a literal quote, right? Why? This is what's being sent. And then an actual look, foo is actually properly set, right? Or not? Is it properly set? I think it is. No, it's not. I should have a slash. Oh, this is a nightmare, man. Ah. I think this is still wrong. Yeah, exactly. It should be this. Yeah. Okay, let's maybe try to fix that one. Yeah, we need to fix it here. Of course, it's the same thing. Whatever is breaking here is also breaking here. I want to at least know that we only have the issue there and nowhere else. Yeah, because the editor doesn't care, the sorter doesn't care, the validator doesn't care. We do have an issue with here to number and parse number, we will have an issue here. What's still broken? The extra characters accounted for when measuring indentations, matchings of indentations. If there's unescaped quotes or slashes, that's one. In text to number, no, text to number, what the hell am I saying? Text to paths. In pathsToText, all of the escaping paths back. I am tempted to do something that spans both functions. This the unescaper belongs. This one is not of general import because I want to add LLM. The LLM. I want to move on. Please. But it has to be solid. I need to be able to build on this. We're almost there. I need to be able to throw anything at it and it has to work well. This takes almost as much willpower as caloric deficit. This guy has this assumption here, and also has an assumption here that I'm already inside. An unescaper, how will it work? Let's at least try to think of the test cases. To unescape an element. If there's a double quote, add a slash before it. Any white space characters, surround it with double quotes. This already we cover. Let's confirm that real quick. Do we even cover this? Yeah. Yeah, this is not too bad. I think I was, as usual, making a big fuss. We already do these two things. So what we need to do is, if there are double slashes at the end, text replace. If there's a let's move this one here. Number. Okay, now if we comment this, let's write a test that breaks it. Let's just give it as an input, something like 2 of this, and can I have one? No, I don't think you can have one, right? Yeah, you can. And then what? Wait, I think you cannot have this. Yeah, you can. You have to give this. So 1 should become 2. I think I'm gonna stop here, but we're almost there. Thank you for watching.